All right, welcome everyone. Thank you all for joining, and we're hanging out today with our good friend Todd Kler. Todd, how's it going?
Howdy.
All right, so everyone, two HVAC and automotive nerds walk into a bar, right? Right. So, well, how can it go wrong from here, Todd?
I don't know.
All right, well, welcome everyone. We'll get back to the actual intelligent side of this thing, but we're going to have some fun. Brett, how's it going out there? Cody?
Hey, Brett.
Nice seeing you all. So, we're here to have fun, but we're also here to talk about transitions that's happening in our industry and to help ease a lot of the discomfort that is out there, especially when it comes to new technologies. So for those of you who don't know, Todd and I, we got a little bit of age to us as technicians, right? We've been around for a little while, but both of us have also been part of the automotive industry. We've both worked on vehicles. We've, as technicians, I'm sure a lot of you are the same way. We learn, Dad, that's right, Brett, I'm working on them, my friend. My teenagers tell me I got some more to add. So we have learned to embrace change with the things that we work on. Now, as technicians, a lot of us are very mechanical, right? That's why we do what we do. But it doesn't always just stay there. How many of us started by building bicycles when we were young, right?
Yeah.
And then worked on our own vehicles when we got to that point. So I used to flip vehicles. Even in high school, I used to flip vehicles, which means I had to learn how to work on them, right? So when we start talking about the evolution of the automotive industry, there are some very significant things that have happened in automotive that are almost identical to what we're seeing in our current transition in the industry. So today we're going to spend some time talking about evolution of two separate industries and how they are kind of merging now, finally, at this point. Yeah, exactly, Cody. What is our first tools? Were they plastic? No, most of the time it was things that we pinched fingers with and broke stuff with. Yeah, we've talked about, scavenging through, spare stuff for parts for things to tear apart and try to fix. And that was just kind of part of it. So let's look at what happened with automotive so we can see where we are right now. And hang in here, because we're going to show you some things that are going to help inverters make a lot of sense, because a lot of people are afraid of inverters, and we really need to be aware that inverters are the new standard. It is. We spent time almost a year ago with David Brennan from Rheem looking at the new lineup of equipment and realized that, man, almost everything was gone that had a contactor, except for the hybrid systems that had an inverter board plus a contactor that ran on inverter up to about 75 to 80% and then switched over to contactor to run full 100%. So it took the inverter board out, so it wasn't using any excess wattage. I've already talked to some of our friends over at Johnson Controls going, hey, yeah, we're really heavy on inverters. And Daikin is saying that they're here to inverterize the world. That's the mission of Daikin, right? So let's look at vehicles real quick, and let's look at some of our lineage, right? We seen some big transitions in the 1970s, and that was really based on fuel efficiency, the demand for fuel efficiency, because the cost of fuel was ridiculous. Energy to run those engines, right? So we're really just talking about that internal combustion engine, the cost of the fuel to run it. Yeah.
And some of our audience may be too young to know, but back in the 70s, the fuel shortage. There was odds and evens of your license plate to get fuel.
Yeah, it wasn't like you can just go down to the gas station like we can now. You waited in line to pay premiums like we pay now for fuel. So we took the internal combustion engine, and this is the important part as an analogy in our classrooms, and especially when we're talking with our technicians and students. When we started evolving our internal combustion engine, it wasn't about reinventing the internal combustion engine. It was about making it more efficient, right? So we started working with emissions quite a bit. That's when we started utilizing catalytic converters, and that's when we started making our vehicles lighter. We had an increase, and then we leveled out through the 80s, right? We're still talking about carburetors. We're still talking about mechanical ignition systems. We're still talking about big, heavy boats, right? Pretty heavy vehicles in the 80s.
Steel.
Lots and lots and lots of steel. So once we got into the 90s, we started looking for other opportunities to change the fuel efficiency of that internal combustion engine. right? So how did we do that? Well, we're gonna dive into that. We're gonna show you some of the things that we did and how similar it is to what we're doing in HVAC. So let's look at HVAC, right? Let's look at the one on the right-hand side, HVAC industry, just looking at SEER in cooling and heating capabilities. We've increased a little bit over time, but relatively stagnant. If we look at the increases, like in automotive, we're talking 3 times efficiency changes in many applications, right? We haven't went that far in HVAC.
Not yet.
No. But we have started trending upward. Well, we're getting ready to make a big trend upward, but we need to understand how we do that. So let's take a look at where we went from and what we went to in automotive, and we'll show you those analogies in HVAC, right? So let's think about these vehicles of the early 80s, early 90s when we started making that transition. We were talking about internal combustion engines, right? We're talking about pistons that were being driven by connecting rods, being rotated by a crankshaft, ignited by fuel, ignited by spark and air, and relatively crude controls. You know, we still had points ignition systems in the late 80s, and we were using chain-driven timing systems.
And it was reciprocating.
Yeah.
Our good friend Ty did a great video yesterday on one of his medias, and that, hey, the reciprocating compressor is dead. That's because it's not going to come back.
It's not. It's phasing out, right? We're looking into more efficient designs.
All that clearance space every time it comes up, that piston comes up and down.
It's right. It's wear, right? So we looked at better ways to lubricate. We were looking at that internal combustion engine. We're going to pick on like some small block Chevy, small block Ford stuff just for analogies so that you can see what we did, right? We didn't completely re-engineer the internal combustion engine. We changed a few things to make it more efficient. We added fuel injection. So we took off the manual carburation and we put on digital fuel injection. We put on electronic ignition so that we could control the advance of the spark, so that we could fine-tune that ignition so that we had the best fuel efficiency, whether we were in the torque power band, the high RPM power bands, where we were cruising. We could modify the ignition electronically. And later we went to variable valve timing. Yeah. So we removed those mechanical components. All right.
And went digital.
We went digital. Now, Todd, what did we do with the internal of the engine?
It's the same. I mean, it's still the same today. It's all reciprocating.
It's still a reciprocating block. It's still got a crankshaft with connecting rods and pistons, and it's still made out of a lot of the same materials. Even.
I mean, I use the analogy, for those of us who remember the old Mazda RX-7s, they had rotary engines. It's very similar to the rotary technology compressors that we have.
The same design. Exactly. You know what?
Simple.
Man, I wish we would have talked about this beforehand. I'd thrown some rotary in there. Because it was about efficiency. So, Mazda came out that rotary engine, you put in the RX-7s real early because it was a very efficient, high RPM engine. We got a lot more RPMs in our rotaries today, don't we? All right.
But they were fuel hogs.
They weren't the best. A lot of those were still carbureted too. We started getting into some fuel injection, but more throttle body and not multi-port. All right. So let's talk about our hogs. All right. Let's talk
electrical hogs.
Let's talk about our electrical hogs that have been around and think about this. There are still some reciprocating compressors out there, not a ton, but there are some of them. If we think about the efficiency of our single stage and 2-stage equipment, we're not getting too high, maybe topping out in the 16 SEER.
18 if you're lucky.
Depending
on the matchup. Depending on the
matchup and airflows, you might be able to get up there, but that's like really pushing it to be able to get to 18, right? So if we look at what our traditional, and I'm going to call these traditional or legacy air conditioning systems, we're talking about a lot of fixed orifices. And I just had this conversation last week. Paul Grimm, I don't know if you're out there, buddy. If you are, hop in here and chime in on this. I had a good friend of mine from a major distributor call and said, hey, we're worried about some of our dealers because they're throwing a fit about this new SEER 2. And they said they're going to change brands because they can get piston matchups at some other brands. I said, well, go ahead. They've got it left for probably a few more months, and then they're going to be back to ground zero because they got some old stock they're trying to get rid of, right? Yep. So fixed orifices is what most of us grew up with. I mean, tons of fixed
cap tube on a lot of things.
Cap tubes on stuff. Absolutely. So we had fixed orifice, contactor driven, single speed operation systems. So we had motors that ran at single speeds. Yeah, we'd have different speed selections, but they ran at one
speed,
desired speed.
One tap.
And we had compressors that run on single speed, single RPMs, even if it was a 2-stage. So if you're not real comfortable with a 2-stage system, all we're doing is bypassing some of our discharge gas back into the suction so that we reduce our compression ratio, which in return just does what with our capacity?
Goes down, but your refrigerators are only that much, but you got hot gas coming right back.
Yeah.
And it's even more efficient, but not that much.
Not tremendously.
Nah.
Yeah. So what we are doing is industry is evolving, and this is not just in residential air conditioning, light commercial air conditioning. I mean, this is in refrigeration as well. We're starting to see a lot of inverters. In residential refrigeration, a lot of our refrigerators are already inverter, if you didn't know that. A lot of our window air conditioners, especially ones that are going with things like R32, a lot of those are going inverter already. So what is inverter, right? Well, that's what we're here to dive into to help you understand that all inverters really run the same. It's just a change of the controls on our internal compression engine, right? Isn't that what we're talking about with the vapor pump? We're talking about an internal compression engine. So how do we make it more efficient? All right. We take out our piston. We start utilizing things like thermostatic expansion valves and particularly electronic expansion valves, which I love. Mm-hmm. We're going to use control boards and we're going to use variable speed motors in our fans and in our compressor.
But how do you speed up or slow down a compressor or a motor?
Right. Where is that magic?
You can't just adjust the voltage, right? Because what happens? Well, for all of us who know Ohm's law,
talk about that. Let's do an Ohm's law.
Go for it.
You go on display.
Make the math easy. 100
volts. All right. Hold up. My shield fell on me. All right.
100 volts, 10 amps.
Okay.
What do you got for watts? 1,000, right?
That's right.
Okay. Let's get rid of the drop the voltage in half and go 50 volts. What happens to your amperage? 20. Because the wattage is the wattage, right?
Exactly. All right. So we can't fluctuate the voltage. So how are we going to do this? How are we going to modulate a variable speed motor? Remember, we're talking a variable speed motor in our air circulation and in our vapor circulation. Right.
And a lot of us might know that already. And I know I saw some refrigeration techs that I've worked with that chimed in already. And they've been doing it in refrigeration and commercial industrial refrigeration for years. VSDs and VFDs, right?
Variable frequencies. We're not changing voltage.
We're going to change the frequency. And here in North America, we use 60 hertz. Well, if you wanted half speed, 30 hertz. But how do we change the frequency? You do it with a drive or an inverter.
All right. So let's look at components. So we have a very thorough understanding of the change in components. Because those of you that are used to working on conventional or traditional systems, you know what components you have. You're comfortable with them. If you're working on a vehicle, you got things like distributors and mechanical starters and points ignitions. We might happen to have an electronic ignition, but let's use points for this particular one so we stay mechanical. And we're going to have like ignition coils, right?
Yep.
We're going to store voltage and we're going to fire it off mechanically. We're not going to have a lot of control over it. Well, what about over on our air conditioning? I guess my hands are backwards. Let me over this way. Let's go over to the AC side. We're talking about a contactor that is driving motors, single speed operated motors with assistance of capacitors, right? We're talking about basic fundamental operation of a air conditioning or refrigeration system.
On or off?
On or off. It's a light switch. Either one, light switch, right?
That's right.
So let's think about what's changing to make sure we're comfortable with this transition. Because when we get comfortable with all the components that make up this transition, you'll be more comfortable with the transition.
Yep.
Right? Okay. So here's where we are. This is where we're leaving. This is where the uncomfort zone is going to be. But we're going to break that. Week after week, we're going to break that uncomfort zone. And we're going to make you advanced technicians. All right?
That's right.
So here we go. Automotive started evolving. We had the automotive evolution. we went from our mechanical controlled systems into electronically controlled systems, and we added a processor. It's got a variety of names. CPU is a common one, central processing unit, or main board, computer, all sorts of things you will hear this board called. But what is it? It's a calculator, right?
Inputs, outputs.
It's inputs and outputs.
Garbage in, garbage out, right?
And that is exactly right. If I feed this thing garbage, it's going to put out garbage. If I feed it good ends, it's going to send out good ends.
That's right.
So when we talk about our inverter, all we're doing is we're using the exact same construction. We're using our calculator to be able to make our controls. So let's look at the components that make up our inputs and outputs for our processor in either one, just so you can be more comfortable with the analogy. Let's look at how these things are going to read temperatures. Right? So we're going to use some type of sensor, a thermistor, or we're going to use thermocouple. We're going to use something, typically it's thermistor, so that we have a nice variable
and
DC
accurate
voltage and accurate,
yeah.
Right? So if we look at our processor, our CPU on a vehicle, we're going to use things like intake air temperature, our low side temperature. We're going to use things like exhaust gas temperature, our high side temperature. So we have inputs. And remember, what kind of voltage, Todd, is our vehicles already running on?
All direct current.
It's all DC, easy to modulate, right?
Yep.
So a lot of our sensors, we're just going to drop that voltage down. And what's funny about it is a lot of these thermistors on automotive are actually operating at 5 volts DC. All right. Depends on the manufacturer of the system, but there's a lot of them out there that are operating on a 5 volt DC platform. So we send in a positive 5 volt DC. We have a ground or a neutral. And then based on the temperature, we have a variable DC voltage coming back out as an input over to our CPU. So we have low side temperatures on a vehicle. We have high side temperatures on a vehicle. And we get over to our inverters. We've got
thermistors.
we're back again.
Yeah.
And most of these are actually going to operate on 5 volt
DC voltage.
Right? So it all comes down to converting it.
But wait a minute. Yes. How do we get to DC voltage?
You run. Let's hear it.
Well, this board, this inverter is going to do a wave rectification from our alternating current and
incoming AC.
Incoming AC, sine wave, right? Mm-hmm. Whether it's 240, 120, whatever it's going to get. And it's going to convert it to a usable through a wave rectification of the inverter and turn it into a DC that we can use. And the beauty about DC is we don't have to worry too much about Ohm's law with adjusting the voltage. We can just adjust the voltage. I mean, you guys all have drill motors out there when you take cabinets off, right? What do you do with that trigger? You can vary the trigger a little bit, right? Well, does the motor burn up? No, because it's direct current.
Exactly. And when we put it into a 3-phase application, even better, like say our compressors, most of our compressors are going to be a 3-phase motor, and we're not even changing the voltage.
And we don't need a cap.
No, not needed. We're just taking our high voltage, and remember, it's about 130% of the incoming AC voltage on average. So if I've got 120 volts AC going to it, and I've got 120 volt AC mini split sitting right over here on the shelf that I use to tear apart for doing training purposes. So I got 120 volts in, and I've got like 150, 160 volts out for my DC. If I'm talking about a 240, 230, 240 volt power supply, I'm somewhere in that 300 volt DC output. Right. So then I got all kinds of current, right? I got all kinds of voltage. I got my pressure. My voltage is pressure, remember? So I got my pressure behind me. And if I want to fire a 3-phase motor, I just control the timing that I fire each of those 3 phases with a lot of nice power. Makes it nice and efficient, right?
Yep.
So now we've got our input in temperatures. So we can look at our low pressure temperatures or our low side temperatures, our high side temperatures. Now we can start throwing them everywhere. When I did grocery refrigeration, I did a lot of new grocery startup and commissioning, and I worked on some old ones too, but a lot of new stores. If there was something I wanted to monitor the temperature of, I just threw me out a thermistor and give it a location and went monitor this. And if I wanted to monitor 2 of them, I put 2 of them and I said, subtract this one from that one and give me what that number is.
The average or the average.
Yeah, or average it. So all we're doing is we're just looking at different points so we can have precise calculations in our control. So let's take it a little step further, right? You ready? What about pressure? Anybody ever thought about pressure on a vehicle?
Sure.
A lot of people, I do. You do.
Fuel rail pressure.
Yeah, income map pressure, manifold absolute pressure, exhaust manifold pressure. There's a variety of things that we look at on a vehicle. So let's look at, say, the map, manifold absolute pressure. We're looking at the air coming into the engine. That's on the low side of the system. We could also look at the EGR, the exhaust gas side of it. We can look at the pressure on that side. And now we have a pressure calculation, same 5-volt DC, nothing crazy. Whatever the voltage is that it's using for the temperature thermistors, it's probably using the same voltage for the pressure transducers, right? Oh, hey, Scott. Yeah, you're right. What about boost pressure? Now we're going really positive. Instead of being negative on the low side, we're just going to be positive on that low side so that our output is multiplied. What pressure? What happens if I increase the pressure on the low side? I'm going to increase the pressure on the high side as well. I'm going to increase input. I'm going to increase output. So now we've taken some temperature measurements and we've taken some pressure measurements, and our processor has done some calculations on our controller. Well, what about our inverters?
Pressure transducers.
That's what it is. It's another 5-volt DC pressure transducer so that we can read pressures on the low side and on the high side of the system.
And for those of you who don't know what a pressure transducer, say you didn't get there, a lot of us have with, guess what? We're getting away from true old school manifolds, exactly where I'm going with this. And we're using these right in here in your hand. Your hose is nothing.
No, absolutely. It's gone. Man,
and so that, it just turns into a Bluetooth signal and goes to your app. You measure quick, the Testo, Field Piece, whatever app you use.
Out there.
And it spits out a known number that you guys are used to seeing on your analogs. In fact, all digital manifold gauges, even with hoses, are pressure transducers.
That is such a good analogy. So what are we doing, right? Let's grab the old handy dandy Testos. I had my Testos and iManifolds floating around. So if I'm talking about wireless gauges, digital gauges of any kind, any brand, any model you want. You ever notice what kind of batteries we're using in these?
Usually AAA or AA's.
DC voltage batteries. Yeah. So thermistor, we're sending a voltage. So we're using typically two AA's, 1.6 volts apiece, so about 3 volts. So we send a 3-volt positive DC supply to our temperature thermistor, and a variable DC comes back, and we send that variable signal back to our manifold, our calculator.
Or pressure.
Or phone, whatever we're using. Pressure transducer, exact same way. All I have is a pressure transducer operated by DC voltage. Whatever that variable DC voltage is, it comes back as a signal back to my processor. Well, what happens when we put those on the piece of equipment? And we leave them there.
Well, guess what? We do that all the time. They're on our high sides and low sides.
On a lot of equipment, people don't even realize. This is where it gets fun. This is why I love talking about this stuff. We can make this real. We can go, oh my gosh, is it really this simple? Yes, it is. So what are we going to do with our inputs on our CPU on a vehicle? We're just going to use it to control the capacity.
Yep.
We're going to control the pressure, the fuel going to our fuel injectors. We're going to control the voltage and the timing going to our ignition coil, which is now tied directly to our spark plug so we don't lose it in wiring.
Yep.
When we get over to our inverter, well, and we're just going to operate electronic expansion valves. Remember, DC voltages still. We're going to operate fan motors, sometimes with DC voltage, sometimes with 3-phase. So it just depends on, which style we use, depends on what the board wants to do. Depends on the horsepower of the motor that we're driving. as much as anything.
And it also depends on the motor type too. If it's still an alternating current motor, then we got to turn it into we got to
then we have to rectify
frequency.
Exactly. And so there's some different
Exactly.
But like our DC voltage, we can check all that on our board.
Yeah.
We've actually got DC test ports. I got to tear one apart and do some more inverter board training because they're simple to check them, right? It's just like checking a car battery. We can actually check DC voltages on an inverter board. All right. So we got inputs, Todd, that goes to a processor that controls some outputs.
Yeah.
On a vehicle and on an inverter. Okay. So let's talk a little bit. Oh, I guess. I bypassed my little lines. All right. So there's our inputs. There's our outputs. There's our inputs. There's our outputs.
There we go.
All right. Now, let's talk about working on these things.
I've worked on Minisplits. I mean, I'm sure there's a lot of people out there, and Minisplits is kind of the where the all started and developed, right?
Yes.
And with those Minisplits, yes, we have VRF, VRVs, et cetera, but really it kind of spawned off of Minisplits.
Yep.
Minisplits been around for a long time.
That was our first inverter technology.
Yeah, it really was. And I've worked on several where you pick the phone, you call tech support. Hey, you know what? This is my problem. Yada, yada. I did this. And they tell you to, check this on this part of this board. Check this on this part of this board. Okay. We're going to send you all 3 PC boards because we don't know everything. We don't know what's wrong with it.
Yeah. Something's wrong with it. Well, that's no
what
way.
If we had changer, isn't it? But what if we had something that we could plug in?
Yes.
And tell us what's wrong with it. Or
exactly.
An idea what might be wrong with it.
Right. Let's get us in the ballpark.
Don't we have that in automotive?
So let's think about that, right? So if every internal combustion engine on a vehicle, except for diesel, let's just stick with gasoline for this particular reference. Diesel is actually similar, but gasoline is an easier reference.
Yeah.
So let's talk about what happened in the automotive industry to make that better, right? Because there was a time where it wasn't very easy.
Nope.
And a lot of people, our generation of automotive tinkerers will remember this. Our younger generation may not even be aware of this. And this is important to know. There was a time, my gosh, I'm starting to sound old. Back in my days, my buddy used to hold a flashlight for me to work on the car. Now I got these rechargeable LED thingies. Anyhow, so when we were talking about diagnostics on our earliest electronic ignition systems for vehicles, everyone had their own.
Their own language.
Had their own language. Even though they all came, if you look it up, you'll find this term called OBD, which many of you younger technicians that are out here with us, you're going to recognize OBD2. You're going to hear that often.
You might not remember OBD1.
You might not know what OBD1 was. OBD1 was a pain in the rear because all it meant was that every manufacturer had to come up with a language to speak to their communicating components. I mean, it's just DC voltages talking back and forth. It's no different than a telephone line, an internet connection. We're just sending signals back and forth. But what are they saying? Right?
Right.
That's Cody. Yeah. Hey, Cody knows what we're talking about. All right, Cody. Bottom one there. Oh, the one that says OBD1 that's got the red, the yellow, the blue. Right. There you go. Scott, you know exactly what I'm talking about. Right. So it was a difficult, and you, depending on what truck you had, if you had a Ford, you got the Ford scanner. If you had a General Motors, you got the General Motors scanner. So the one in yellow is the Ford, the one in red is the General Motors. You had a Chrysler one, which I was even having a hard time finding, even out there on eBay. So now, probably because everybody that worked on Chryslers when they went to newer vehicles, they dumped all their tools.
And this where we're going with this is it might sound familiar that those of us who worked on IntelliPax or Linux
that have
has long, right? Yeah. Or what's the beauty about Niagara?
Talking.
Yeah, you got a translator basically.
Exactly.
And the automotive ended up going to OBD2, which made a standard language that we all can read.
Game changer.
Game changer.
Right.
Well, guess what? HVAC is not quite there yet. Yeah, there's a lot of manufacturers out there that have their own language, and you can plug in a code reader. Look at IntelliPax, right?
Yes.
Those of us worked in heavy large commercial
stuff. Yep.
Your boxcar units.
Yep.
What do? They plug this thing in.
Plug it in.
Let's
read the inputs and the outputs and see what they're doing.
But you can't take that same code reader and go over to the Linux next door.
Exactly. Residential is actually very much the same. So I spent, about 4.5 years as a TSA for a major manufacturer and distributor before I came here to ESCO. And what I did was I taught residential contractors how to work on communicating systems, because there's a lot of residential communicating equipment out there. Many of our manufacturers, even like with Rheem, they said, man, we went from having like 30% of our equipment being communicating to next year's lineup is going to be over 70% is going to be communicating capable. So maybe it runs on a communicating thermostat, maybe it runs on traditional, but the indoor to the outdoor, that's all communicating stuff. Same way with Goodman and Mana, they're all communicating in some form or another. Now, how do you read that stuff? Well, it depends on the manufacturer still. There was this thing in the 90s called the Climate Talk Alliance. I actually did a show on that a while back. I think the one that was with Jim Brown, and we were talking about communicating zone controls and talking about the Climate Talk Network. So anyhow, the Climate Talk Alliance, oh yeah, I know.
Yeah, Cody.
Buddy, you're right on it. These older guys are going, oh man, are we doing this again? I threw away all my code scanners. I don't want to start all over again. So we have different manufacturers with different languages all talking on the same platform. If you go back to that one that I did with John Brown, we talk about a lot of the different manufacturers of communicating systems, and really they almost all have a 2-wire 5-volt DC as the actual communication.
2 or 4.
Yeah, and a lot of the 4, the other 2 are the voltages for the screen,
correct,
whether it's AC or
that is true.
12-volt DC. True. So a lot of a communication is done typically on just a couple of wires, but the languages are different, right? So now we're all stuck. So there's a lot of different languages out there. Why can't we change that? Why can't we be like the automotive industry and go, okay, this is great. This they all work the same. We get it. Everyone wants to have their own special platform and special tool to read it. But what it all comes down to, it's called the right to repair, right? It's called being able to understand if I know what's going on there, I just need to be able to see it. Brett, what are they typically controlling the variable speed? Is it, okay, let me just bring this up, right? So we'll do some deep diving to dive into what we're actually looking at. So a lot of times our variable speed, it depends on which component. Well, actually, a lot of the speed of the compressor is dictated by the discharge temperature. Almost all of our inverters have got a temperature thermistor on the discharge line, and that will help dictate the actual speed. If we're using an electronic expansion valve, we're using a temperature thermistors at the inlet and the outlet of the coil. We're hopefully using a pressure transducer either at the indoor or the outdoor. Some manufacturers have both. So I got to start deep diving into these. Brett, we need to have you on here sometime, and we'll spend some time talking about ducted and ductless inverters, because it's different depending on which one you're looking at. Most of the logic's actually very consistent. What changes is, if we're talking about communication, what actually changes is what we're saying on that signal. Because even if two different manufacturers are using 5-volt DC, we'll vary that. Yeah, I will come back and check that out, Brett. Here, I'll actually pop that up here for anyone that wants to know. So Brett's got a podcast.
Yeah, he does.
Diving into that one. So I don't know that one. I've heard some of them, but I don't know that one. So I'll spend more time diving deeper into, because it's basically 2 different platforms where, we got our unitary that is our ducted systems, and we have our ductless, and then we get into some of our inverters, just different DC
tell
voltages.
Us, what's the plan with HVAC or HVAC refrigeration for this common language, possibly?
Exactly.
Or if not a common language, an interpreter, kind of like BAS's, DDC's, Niagara, where you can kind of speak long and all the other types of languages. Where are we going? What are we doing?
Right now, we're held up by manufacturers. Many of those are using proprietary software, proprietary algorithms for the code that they're sending. And all it comes down to, think about this. How do I speak on a DC line? I don't even vary the DC. I just take the DC voltage and I go, I'm going to go up. And how long am I going to stay here? And then I'm going to come down. And how long am I going to be in between the next time I go up? Anybody ever seen Morse code?
Yep.
That's what we do in communicating systems. It literally is just Morse code.
How long am I
up and how long am I down? It's all
ones and zeros.
Ones and zeros. So different manufacturers have different designs. Now, are there Are there people out there breaking those codes? Yes, they have been for years. haven't seen anything legal for it in manufacturing yet, but hopefully someday we will see universal we will see it. I mean, we've seen it in automotive. I mean, I personally am pushing it right now myself in the industry. I sit on many committees, one of which is, contractor development. How do we work on these things better? Brett, you're so right, my friend. That's all pulse width modulation is. It's right. It's 1 and 0. If I'm up, I'm a 1. If I'm down, I'm a 0.
So tell us, Clifton, let's just assume the cutoff is what, 2028, if I'm right, that we're supposed to have a common language of some sort.
So there's a lot of interesting conversation in that when you start talking about federal agencies and manufacturers. Of course, it's torn between the two, but I am not going to be a bit surprised to see a mandated common language in our industry.
And
why don't we mandate it?
And it's got to come from the federal.
Why doesn't it come from the contractors and the technicians?
Should, but in order for it to be pushed through, it would have to come from. It would definitely have to.
It'll be a federal initiative. Exactly.
But, okay, let's just assume that we do get a common language. We get an OBD2 terminal type plug, a standard plug, and it spits it out and it tells us what's wrong with it.
Right.
So does that mean that homeowner can diagnose this stuff?
That's the thing. Then it gets back to, can a homeowner go out and buy an OBD2 scanner for their vehicle?
Sure.
And are there some components that can be easily repaired without harming yourself?
Sure.
A few.
Maybe that you got all these sensors and you got static pressure, and there's static pressure to the roof, and it says, hey, high static pressure, you probably have poor airflow. Maybe change the air filter.
Exactly.
Oh, maybe I should change the air filter. Well, sure. But, okay, you got an issue with your pressure transducer such, maybe on your high pressure side. A homeowner can't go and change that pressure transducer, can they?
No, absolutely. So there are things that you could be aware of. Take of my own vehicle. There are some things that if it is a simple thing, if I can take off 2 screws and 1 electrical plug and I can do it myself, I might be interested in that. What happens if that's not the part?
Didn't you have
taking it to a professional?
Didn't you have an issue with your cabin air filter the other day?
Oh my gosh. Right here. Let's talk about right here. Good one just came in from Scott too. Scott, that's so right. What happens if they change the wrong part, put the wrong part on? They're still calling you.
Yep.
You're going to look at it and you go, all right, well, I'm glad you spent that $70. So, throw it in there in your tool chest and let it look pretty. Now I'll actually fix it. Yeah. Right. So let's look at that. Right. So in my own scenario, we bought a new vehicle during COVID. Kia had some crazy good deals during COVID. If anybody bought any of those Kias that were like $5,000 off and 0% for 60, oh my gosh, it was great. Anyhow, I bought 2 of them during that. Anyhow,
I bought one.
Yeah, exactly. Good vehicles, but so we're on a vacation. We're about 1 year in on a brand new vehicle, right? And so we're heading up the mountains. We're actually headed down to South Carolina on a little vacation. We're heading up the mountains and the air conditioning starts getting off a little bit, right? And go, I need a lot of airflow coming out of these registers, right? And then after a while, it's like, wow, there's no air coming out of these registers. What can it be? And then AC guy kicks in and goes, it'd be nice to slam a code scanner on this thing and find out.
Right?
Let's go back to basic principles, right? Let's go back to basic principles. If I was working on an air conditioning system, what would have I looked at?
Well, you probably start with airflow.
Airflow.
Indoor and outdoor airflow.
Indoor and outdoor airflow. Remember, it all comes down to understanding fundamentals, right? There's a point to this, I promise.
Heat exchangers.
We're talking about heat exchangers, right? So it ended up being a cabin air filter, plugged solid, had a whole bunch of outside debris, had lease and had just a bunch of debris in it. Turned the fan on high with no filter. Open the doors, let the heat rush in, have a nice swimming pool underneath the vehicle, and we're back on the road. But when we think about vehicles, buddy, Brett,
yeah, he gets it.
You need to be on this show with us sometime. We have a lot of fun here, if you can't tell. It all comes back down to the principles of operation, right? We talk about inverters, we're still talking about principle of operation.
Yeah, we are.
We look at you want to run into this one? I know you're real passionate about airflow and the types of radiators that we're using.
Yeah. Well, guess what? I mean, our radiators in our car today are what? Microchannel.
Microchannels.
What happened about, what has it been, about 10 years now when, who was the very first one? It was York that was one of the first ones that introduced microchannel.
York and Aon were really early on the microchannels.
And guess what? with microchannel, it had its growing pains, and it really did.
It's a change, especially when they're all aluminum.
They're all aluminum. The mounting brackets from vibration, they crack, yada yada yada. But what's the beauty about microchannel? The size. In order to get the efficiency out of condensers, we had to make it big
for the heat, right?
We had to make it really big, right?
We're in the business of moving heat. That's what we do.
That's why your COAs or condenser over ambience on a higher efficiency is much less, because guess why? There's more surface area typically on a larger efficiency, higher C rated piece of condenser, right? So the microchannel, well, we were able to get that cabinet size back down.
That's right.
Yeah, there was some cost to pay with, some growing pains with, technicians not using nitrogen when they braze and them getting blocked up.
Basic principles, basic practices.
Yep.
That's what we're coming back to.
But, there's now, ADP, All-Style, and some other manufacturers, they make evaporator microchannels too.
Yeah, absolutely. We're going to see a lot more of that. So it's another piece of this transition. And we think about, so I run a cold climate, low ambient Daikin 4-port 3-ton here in the shop and in the studio. It's all microchannel. Indoor units microchannel, outdoor units microchannel. It's all aluminum, right? That's been a transition to get used to.
And the point here is, whether it's microchannel, whether it's controls, whether it's inputs, outputs, HVAC has been playing catch up to the automotive industry
for a long time.
We're getting there.
We are getting there. And I firmly believe, this is the reason we do this show. I firmly believe that we are ill prepared for the transition that is amongst us, and that we all have a lot of education to do. We have a lot of relearning skills that should have been required in traditional systems, but some of those traditional systems just got by. Think about a 350 shape. Think about an old small block 350, right? It was one of the most inefficient things, but man, you could run that thing for 50,000 miles without changing oil if you really had to. It was just an absolute diehard.
You wouldn't want to, but
you could, right? And same way when we start talking about air conditioning, refrigeration systems, and in single speed operations, we were able to get by with a lot of bad habits with our traditional systems that we're not going to be able to with newer systems, right? Nope. They're going to be, and it's not. I've heard that it's a critical charge, it's a critical installation, and I kind of disagree with that. I say it's a proper charge and a proper installation. That's all that it really is, because all installations and all charging are actually very critical when it comes down to it, if you're doing it right and you're making calculations and
mini splits where the inverter technology really spawned or grew.
Yep.
Guess what? Are there ports for a mini split? Well, there's one, right?
Yep, that's it.
But is there a suction?
No. Oh. So we're going to get into.
How do you measure your superheat subcool?
That's exactly right.
The pressure transducers and
the temperature. You mean those things that are already there,
already inside? Why can't we plug something in that spits out, hey, your suction pressure's off, or hey, at this speed, or this capacity, because those are variable capacity. At this speed, the pressure should be around X or within this X window, right?
That's exactly right.
And then have it spit out, hey, it's out, it's not working right.
Yeah.
And here's the list of, Measure Quick kind of does that. Testo, Fuel Piece, they kind of spit out like kind of a guesstimate what's wrong with it, right? Hell, our furnaces for years, they had those LEDs, right? We still do. And it spit out a code, right? One long dash, two quick dashes. Idiot lights is what I like to always call them. Sure, you can, it'll be, you got a no gas or whatever it might be, but you still got to figure out why you have no gas. Is the gas valve
have to do the
broken? Is the gas valve turned off? Do you have gas turned on? Whatever it might be.
Yep. So what we're starting to see more of, and we've actually seen it for quite a few years, if you haven't recognized it, we're starting to see a lot more onboard diagnostics on our equipment, right? How many of you have seen some of our residential manufacturers putting gauges on their outdoor units? Have you ever looked into the communicating thermostats by almost every major manufacturer? They actually read all of your temperature thermistors and your pressure transducers in the thermostat itself.
I like what Brett just put that question back up.
Yes.
he's talking about, not hooking up, not reading pressure. He's talking about reading temperature.
Temperatures, absolutely.
Going back to basics. What is a PT chart?
When I service a piece of equipment, gauges are the very last thing that I would touch it with.
Yeah.
Very last. Temperatures? Absolutely.
And when I do put gauges on it, I don't put manifolds with 6-foot hoses on them.
Short as possible. Yep.
Transducers. Why?
Yeah.
Don't lose any refrigerant.
Yeah.
Or very little anyway.
Yeah. Scott, you're so true. I mean, that's the reason I'm here. A lot of that is the reason that Todd's here. I spent most of my career in commercial industrial refrigeration, right? Grocery rack refrigeration is the name of my game. And everything was temperature thermistors and pressure transducers.
I got to go there. But Scotty, I know Scotty. He's a good friend of mine. He worked with him for years at a refrigeration company. Awesome. And the guy turned from working at the auto store, and he was kind of poached by his neighbor. He goes, "Hey, come work for me." And he is probably one of the best refrigeration technicians out there.
Well, he gets it. We're glad you're joining us, Scotty. There's a lot of great people out here. This is what it's about. It's about all of us joining in and going, hey, maybe I didn't think of it from this perspective. Let me tell you what I seen. Let's talk about how these things work. There's so many opportunities in our industry. If we just open our mind a little bit and go, okay, we are in the middle of a transition.
And hold on.
And it's exactly right.
Not only inverter technology, but a few weeks ago, refrigerant.
Yeah. All coming at the same time.
Yep. And you got to buckle up because you got to stay ahead of the game.
That's exactly right. So let's talk about that just for a second. Let's talk about staying ahead of the game and staying prepared, right? We're just going to take a little snapshot in history and look at two industries and see what happened out of that. If we look at the automotive industry, when we went from mechanical operation into electronic operation, our vehicles went electronic. They had processors with inputs and outputs, and the technicians had to get retrained. Yeah. So you had the primary one, still is a primary one, is Automotive Service Excellence, ASE. If anyone's ever taken their vehicle to a service center and you've seen that ASE symbol up there that had certified technicians, it put you at ease that you had someone that was qualified to work on a piece of equipment, that they've actually went back to do training on the current technologies, right? So in ASE has been around since, I believe it was 1972.
I don't know.
Yeah, I think it was 72, because it was around 50 years or so. And so ASE has certified 250,000 automotive technicians in different curriculums. HVAC Excellence and the ESCO Institute has been here since the 90s doing the exact same thing, mainly preparing our students and our educators, not spending as much time focusing on technicians, except for the EPA side of things through ESCO Institute. Yeah. So to date, based by social security number, so these are actual individuals, ESCO Institute has certified about 736,000 universally certified, not type 1, type 2, universal.
And that's only ESCO too. What about the others?
That's right. There's a lot of other accrediting and other certifying bodies out there. Well, if we talk about just the HVAC excellence side, so we talk about the assessments that are technician based. They start at our heat assessments, the student level, through high school, through our college level, through our advanced technician. And then we actually get into our educator at the end. We're at about 83,000 individuals that have went through HVAC Excellence for advanced certification of itself. Here's the reason why, right? Oh, Cody, awesome. Glad to see that you're out there with us, right? Oh, hey, there's the, yeah, you're Cody. So it's called taking a look at those professional level certifications, right? So, and I want to spend a lot more time talking about these going forward, because what does an assessment do? What is the primary goal of certification? It is about getting a badge. We like our badges, right? Sport some of mine today, right? It's about being recognized for your accomplishments, for sure. But most importantly, it's about recognizing what you don't know. So Todd just finished our, congratulations.
Thank you.
Master HVACR educator. Not an easy thing to do. No. I'm still working on it myself, right? And what do we learn along the way?
We learn what we don't know.
We learn what we don't know.
Trust me, I learned a lot what I don't know. I'm not an electric heat guy. I struggle on electric heat.
I blew my mind. Some of the things that I thought that I knew really well, I'm finding that I needed to go back and learn a little bit more about. So that was very much the purpose of ASE, was to help you test where you are so that you can assess what you need to learn next. And that's exactly what we do at HVAC Excellence. When you take from the student all the way up to the instructor, the professional level exams, we actually spit out a report so that you can see the things that you missed.
Subjects of within that subject.
Exactly. I don't necessarily need to know what I did do well. It's nice to see, but I want to know what I did not do well on so that I can prepare to be better at that.
I see some of the reefer guys talking about, you know, reefer certifications, CREO, RETA, etc.
Exactly.
So yeah.
Same thing. You know, it's about making sure that you're staying current with technologies, making sure that you're staying current with proper procedures. And that's really what it comes down to is, oh, exactly. Chris, thanks for joining us. So that's what we're talking about. We're talking about show us how good you are. I always come back to this in the residential application. I used to do a lot of contractor onboarding. And the first thing I would do is I would go into a contractor and I'd say, okay, tell me how good your technicians are. And they, oh, he's been in 15, he's been in 30 years. Like, okay, can I test them for you? And they go, what are you talking about? I was like, you can give me two different guys that have been in the industry for 30 years. One guy that's done the same thing 30 years in a row, and one guy that's went back for continuing education for 30 years, and they are not the same people. Let me know how much of each one of those that you have. And that's really what it comes down to. Understanding where our strengths and our weaknesses. Scott, absolutely. And I completely respect Nate. I just had a conversation with him a couple months ago talking about...
You and I were talking before the show.
Doing awareness for the industry. So Nate has got about 35,000 technicians certified as well in the HVAC industry. So we have a variety of organizations out there. Of course, I'm going to be very proud of mine. We got a lot of big numbers. But it's about making sure that we are testing ourselves. Eugene Silberstein says this all the time. If we don't know it, we can't teach it.
That's right.
Right. So what are we doing?
I learned that when I started teaching, man. I gotta learn it before I could teach it. And there's things, you know, there's subjects that are not my forte, and I'm not afraid of that. There's things I'm better at, you know. And guess what? Here at HVACR EDU, I mean, we collaborate a lot often with ESCO and HVAC Excellence, and we offer a lot of certifications and get you, you know, and we're talking about CEUs and staying on top of things. Things are changing. One of my biggest roles here at HVACR EDU is to update material so that way it's current, so that way when people come back and they're staying on top of the industry trends.
You keep on talking about that. I'm going to go try to grab something real quick.
Okay. Well, you did see Chris Compton join in. Some of those, you know, Chris Compton, great. For those of you who don't, you might want to check him out. Guy's a legend, the man, the myth, the legend, as we like to say. He is the pioneer of online education.
Oh my gosh. Yeah. Talk a little bit about that. How long he's been in the industry.
What has it been? About almost, I think we're shy of 30 years now with, and I've known Chris Compton for a long time. Well, before I started working here, a lot of those here may not know him, but, Chris has been a mentor of mine, and I'm happy to work here and be part of his team. So.
Yeah. It's awesome to have him here with us today. All right. So I think, let me see if I've got this ready, built on the fly. Oh, hold on. HVACR EDU. Let's get that bad boy in there.
And guess what? We're working on some VR stuff too. So some online, not just online click or slide or listen to the video, but we call mouse on, and it's pretty awesome.
Yeah, so there's a QR for anyone wanting to grab that. That'd be a direct link over to hvacredu.net and learn more about resources that are there.
And Chris just chimed in 27, so just shy of 30 years.
Yeah, that's crazy. We think of, you know, VR being a current technology and online training being new, but Chris is definitely a founder.
And you go to that website, this is going to be one of the very first pop-ups that you see, so you can take a look at it. Free download. Awesome.
Yeah. Absolutely.
We're working on other ones, and that's more, like I said, one of the things that I'm working on. It's keeping that stuff current and you know, typical skills, and it's really awesome.
One other thing I want to point out while we're here, I need to update the photo on this one. Hopefully this will go to the right one. I'd love to see you all at the 2024 HVACR Education Conference. Right, so That's what we're here to do.
It's not just for educators. It could be for students and technicians alike. Come, you're going to learn something new.
We had a lot more contractors show up this year than anticipated. We had a ton of first-year educators, which is amazing. I mean, that goes to show. That's right. It shows how much this industry is growing and the need for us to stay together. This HVACR community. That's what we are. We're a community to support each other.
How do you get your educator ticket? Well, go to your credential. Hey, can you pop that up on the screen? The ESCO, the HVAC Excellence.
Let me see if I can take you to the main screen.
It's under the credentialing certification credentialing.
Yeah,
educator credentialing.
Let me pull up a new screen real quick. Hopefully I don't lose you all. Let me go share.
Yeah, and so those of you who are technicians that you may not be an educator, or you might have, I started off a technician and fell into HVAC. I share some similarities with Chris. I was a pilot for years, and I fell back into what I knew, and that was HVAC, something I've done for a long time, and kind of just developed into education through some of the utility companies to private companies, and then at the college, and then of course now here.
Absolutely. So funny how we sometimes leave the industry and then come back. Right. All right. So here's what we're talking about, Brett. So we're talking about, if you go to escogroup.org and you go over to the certifications tab, now we're talking about all of the different certifications. And I'm struggling to get my second screen as I've got something on there I can't get rid of. But we're talking about certifications all the way from the heat assessments, which are at basically the high school level, so our very entry line into the industry, all the way up through educators, right? So it's progressive levels. So depending on where you are in the progression in the industry, you have the ability to really find out where you are. And then if you really want to push yourself, you can be like Todd.
There's only
right?
I think, and I haven't looked in a couple of weeks, but I think there's only 140 of us in the nation.
Yeah, it's not a ton of them. So part of that is passing seven of your CMSEs, then the capstone to be able to get to that point. It is a lot to do. And you want to learn more? Just give us a call. We want to talk to you. We are an old school. Give me a phone call. Let me know what's happening in the family.
As are we.
Kind of business, right? That's the reason we're doing this. That's what it's all about, is making sure that, we have this partnership. I mean, that's why you and I are hanging out. The very first conversation we had, we're like, oh my gosh, you're my kind. Yeah. Let's do more of this, because that's why we do what we do. We're very passionate about. I mean, what would we be doing if we weren't doing this?
I'd probably be deep in schematics like I have right here on my desk and whatnot.
I'd be working on something. I have the opportunity to help people become better at what they do. Chris, that's so right. Shoot for that CMHE. It is not easy. You will find out things along the way that you are not as strong as you originally thought you were.
I walked in and took a few of them, and like AC, I almost passed my capstone because I had the college experience. I missed by one question, right. I think is what it was.
You understood communication
and all those things. But some of these ones that I prepped for, I was like, oh, I went and passed it the first time. Other ones I struggled, and then of course going back to those reports that you talked about, just where you need to develop or where you need to improve on or where you didn't hit the mark. What areas of that subject that you need to work on, and you go back at the books, and
you get better at it.
And that's going back to it. Right. Learn what you don't know.
Yeah. And that's not an easy thing to do. It's not an easy thing, especially us as adults, been in the industry for a while. Like, I did really good. I was a great technician. I helped a lot of people. I must be really good at what I do. Scroll
down to the CMHE, CSME stuff, so that way Brett can see where that was.
Let me see if I can get this moved. Remember, I was having that funky thing with my mouse. Hold on. Oh, hold on.
No, it doesn't like you. Page up, page down?
No. No, I got to go page right to be able to get up.
Oh, because you had the multiple screens. Yeah.
Yeah. It's trying to push it, but it doesn't want to. Yeah. I changed my hub and
I would do it if I had my two screens set up, but Restream doesn't like that.
No, exactly. So I just encourage everyone to go on over to escogroup.org, check out the certifications, check out the accreditation. If you're a school looking for accreditation, part of the accreditation process is having subject matter certified instructors and having CMHE coordinators for the program.
Yes,
right?
it is.
So it's about just checking yourself. It all comes down to, hey, let's check ourselves. right? Why do we go to the doctor?
Checkup.
That's it. Let's see where we're actually at. So we go test ourselves to see where we're actually at. Why do we take driving tests? See where we're actually at, right? So as professionals in the industry, I think it's very important. And I would not be a bit surprised to see some requirements for that. Very much like the automotive industry is starting to see. Yeah. Todd, yeah, he's having a lot of fun. Oh, man. Boy, Chris.
I think he's telling us it's 2:30.
I think he just found out what we actually do when we're on the telephone.
Good times.
I love it. And we really appreciate you all so much. I know it's a lot to ask to be here in the middle of the summer, and those that are working in hot weather, man, we really feel for you. We've been there. You know, we've been in our own attics and crawl spaces and roofs this time of the year. And so just take care of yourself mentally,
hydrate,
physically, hydrate. And once you cool down and have an opportunity, go test yourself, see how good you actually are.
You should say hydrate with the bar picture again.
Oh.
There we go.
I think it's hydrate time.
Is it beer 30?
For those of you who want to join us at the 2024 HVACR Education Conference, we'll be hanging out here after hours. We'll be in the back taking tests and working off.
But there is a cocktail hour at the Educator Conference. Come join us.
Hey, we're technicians. We know how to have fun. All right. Well, thank you all so much for joining us. Any last minute things in the chat? Looks like we pretty well got it all covered. A lot of good conversations today.
And if you need to get in touch with me, it's my name with right there, HVACedu.net. So first name, TODD.
Absolutely, we will. Everyone have a wonderful evening, and we will see you all next week on Did You Know, the ESCO HVAC show.